Radiocarbon dating. Scientists take advantage of the presence of natural radioactivity to estimate the age of fossils and artifacts. The technique is called radiocarbon dating. And the radiation that is used for this is carbon-14. Carbon-14 is radioactive and it's present naturally in the environment. So there's carbon dioxide in the air, and as living things, well, I'm getting ahead of myself. So there's carbon dioxide in the air, which means there's carbon present in the air. Carbon-14 is formed in the upper atmosphere by neutron bombardment of nitrogen. So nitrogen's getting bombarded by neutrons. Where are those neutrons coming from? Upper atmosphere. What's it close to? Outer space. So this is part of the radiation that's coming to the planet from outer space. Bombards the nitrogen, causing it to become carbon-14. Carbon-14 is also radioactive. It decays back to nitrogen through beta emission, but it has a half-life of 5,730 years. So it takes a while. So there's continuous formation of carbon-14 and then decay. And so there's an equilibrium amount of atmospheric carbon-14, and it's nearly constant. There are some fluctuations, but it's relatively constant over time. That carbon gets oxidized to carbon dioxide, gets incorporated into plants by photosynthesis. Carnivores eat animals eat the plants. Animals eat other animals. It works its way up into the food chain. So everything that is alive has pretty much the same level of carbon-14 relative to the non-radioactive carbon-12. So all living organisms have the same ratio of carbon-14 to carbon-12 as found in the atmosphere when they're alive. When an organism dies, it stops taking in carbon-14. The carbon-14 that was there when the organism died slowly decays with a half-life of 5,730 years. And so the ratio of carbon-14 to carbon-12 decreases. We can measure that ratio, compare it to what it was when the organism was alive, and estimate the age. The maximum age that you can estimate this way is about 50,000 years. And that's because anything that's been dead longer than 50,000 years has so little carbon-14 left in it that you can't detect it accurately. The accuracy of this is checked against other things whose age we can check more by historical sources. So I was just up in Grant Grove the other day, and those massive giant sequoias, right? Hundreds and hundreds of years old. You can bore into them without killing them and pull out a boring of them, and you can count how many years old they are. I'm losing my ability to speak. Anyway, use your imagination. Deviations of up to 5% are observed because there are some variations over time. But overall, it's pretty good. So if an organism is alive, it's going to have 100% of the carbon-14 relative to living organisms. If it's been dead for 5,730 years, it's going to have 50%. So every 5,730 years, every half-life that passes, the percentage is cut in half. That make sense? So we should be able to answer questions like this. An ancient scroll is claimed to have originated from Greek scholars in about 500 BC. A measure of its carbon-14 content reveals it to contain 100% of that found in living organisms. Is the scroll authentic? No. So if it was supposed to be from 500 BC, and now it's 2017, right? 2017 plus 500, it's about 2,500 years, right? So that's about half of a half-life. There should be some decrease in the amount of carbon-14. but it's the same as living organisms. That means that the papyrus or whatever material that was used to make that scroll has not been dead for very long. So is it genuine? No, definitely not. People can fake stuff, right? They can fake things by making it look old or various things. You can't fake level of carbon-14. You can't do it.